Okay, this is Mrs. Cronquist, and we are working on section 4.1. This is all about solving systems of linear equations through graphing. I know graphing is not your favorite, many of you, but there's some very basic rules that if you learn those, you can graph anything. All right, first, let's talk about what we are graphing. We are graphing systems of linear equations, or sometimes called a linear system. This is when we have two or more linear equations. So that means equations that can be graphed as a line, like y equals 5x plus 3, or something along those lines. The solution to a linear equation, if you look on the right here, you'll see these two lines on a graph. Well, this would represent a linear system, two lines. So what we know is that the solution to the system is where the two lines intersect. So that's this red dot with a green circle around it. That would be your solution. It is a point, an x and y coordinate, that would make both of these equations true. Okay, so determining whether an ordered pair is a solution of a system is just a matter of plugging the values in for x and y. Remembering x comes first, y is second, and seeing if it stays equal. So, for example, given the linear system that you see here, is the ordered pair -2, -5 a solution? Well, we're going to plug this in, and remember, that's my x value, and that's my y value. We're going to plug that in and find out. As you see, that's what they've done here. So for the first equation, 6x minus 2y equals -2, I take that equation and I plug in -2 for the x value. And I plug in -5 for the y value. All right, now I simplify. So to simplify, I multiply 6 times -2, and that gives me -12. And then I multiply -2 times -5, and that gives me a +10. When I add -12 and +10, I get -2. Well, you know what? Look, that is what it says it's supposed to be, -2. So yes, check. It works there. Now this solution has to work for both equations, not just one. So we have to now check our 3x plus y equals -11 equation. That's this one right here. So again, I take x is -2 and plug it in. I take y is -5 and plug it in. 3 times -2, so now I'm simplifying. 3 times -2 is -6, plus a -5. Sure enough, that equals -11. So yes, this also is a solution. Therefore, -2, -5 is a solution to the system because it works with both of them. So all you have to do is plug it in and see if it holds true for both terms. Okay, so now they want us to do a few, and then I will do a few for you, and you will do a few. Okay, so we have 6x minus 5y equals 25. Sorry, so now I'm going to put in a 10 for the x, so that's going to turn this into a 60. And the 7 for the y, I did 10 for the x. The 10x is what gave me, I'm sorry, I'm going to erase that and do it in color so it's a little more obvious to you what's going on. Okay, so 9 times 10 gave me 60, 7 times 5 gives me 35. And the question is, does that equal 25? So 60 minus 35, yes, it does. So that's a check. Now I'm going to do the same thing with the second equation. I'm going to plug in 10 for 40. Sorry, 4 times 10 is 40, so I get 40. And then I plug in 7 for y. Now, that's a little harder to do in my head, but 7 times 15 is going to be 70 plus 35, 105. So I have plus 105. Whoops. So the question is, does that equal 13? That's my question. Well, obviously it can't, right? I've got a 40 plus 105. That's going to be 145. That's way too big. That's not 13. So no, it does not. So the answer to this one is no. 10-7 is not a solution. All right, let's go to the next number 2 here and look at our numbers. First, we have 200 for x, so we plug that into x, and that's going to give us, well, let's see, 4 times 2 is 8, so negative 800. And now we plug in 700 for y. Well, that one's easy. That's just plus 700. Well, a negative 800 plus 700 is indeed a negative 100. So this one is a check. It works. Now, oh, that's awful. We're going to plug it into some decimals. But notice we have a nice big number, so we'll get rid of our decimals. 200 times 0.05. Well, let's see. We move our decimals, and that's going to give me 20 times 0.5, which is 1/2. Half of 20 is 10, so my answer is 10. Not too bad. Now I'm going to plug in 700 to 0.06. All right, so if I move over the decimal, I'm going to get 0.6 times 70. One more time, and I'm going to get 6 times 7. Well, we know that's 42. And that is indeed negative 32. So again, we have a check, so this is correct. So the answer then to this question is yes. All right, so now you do this one. I want you to think about this. You've got your handout or your printout. Hopefully you printed it out, and you're taking notes right along with me. All right, I'm not going to do it for you. You have to do yours. I'm just going to put some of the color in. Okay, I'm giving you time. Okay, hopefully you get the answer yes for this particular problem. You know what, I'm going to double check real quick to make sure. Yeah, okay, that was on the page. I just can't see the whole page, so it makes it difficult. Alright, so solving a linear system by graphing. So what we're going to do is plot these. And I know you don't like that, but hang in there. There's really only 2 different ones to do, and we'll find ways to make that done quickly and easily. Okay? So hang in there with me. Now, our first one that we're going to look at graph the second equation on the same axis. Okay. So, now hopefully you remember this, but I'm going to talk you through it. When we have it in general form, something x plus something y is equal to a constant. Okay? All we do is we zero out the x. So, we're going to do, this is going to be our purple line. Okay, so if we create a little t-chart, if x is 0, then I can see that y is going to be 2. Okay? If y is 0, I can see that x is going to be 2. Now I'm going to choose one more point in order to be sure I'm graphing this correctly. So something between 0 and 2. So I'm going to choose an x of 1. I get 1 plus y equals 2. If I subtract the 1 from both sides, I get y equals 1. Okay, so now I'm going to come over here and plot these points. I have 0, 2, and I have 2, 0. And I also have 1, 1. Sure enough, those make a line. Okay, here we go. So this is my line. Kind of give you a dotted line by hitting all those corner points. Alright, now I'm going to look at the second one. The second one we're going to do in blue. And that's this guy. Alright. So, I'm going to draw an XY chart for that one. If x is 0, y is negative 4. Technically, negative y would be 4, but we have to make that, by multiplying both sides by negative 1, get it to positive y. Because we want to know what y is, not negative y. So y is negative 4. If I plug in a 0 for y, I get x is 4. Okay, so I'm going to plot these, and I'm going to kind of get an idea of what my second number should be. So I have 0, negative 4, that's down here, and 4, 0. Okay, so I'm going to go right in the middle. Looks like it should be passing through 2, 2, or 2, negative 2. So let's try that. Plug in a 2 for x. I get 2 minus y equals 4. Just be a minus sign there. If I subtract 2 from both sides, minus y equals 2. So y is equal to negative 2. And sure enough, I have 2, negative 2. That means my two other points are correct because it's making a line. Alright, so now I'm going to plot these two lines. Alright, so I have oops, I need to be in blue. So let's plot the blue line. And purple. Alright, there we go. Now, our point is, our solution, is right here at the intersection of these two lines. Notice this is at 3 in the x and negative 1 in the y. So now we're going to go over here and we're going to check that solution. So I am checking 3, negative 1. Alright, we're going to plug that into our first equation. We're going to have 3 plus a negative 1. Does that equal 2? Yes, it does. So check. It works in that equation. The second one is going to be 3 minus a negative 1. That's plus a positive. Does that equal 4? Sure enough. So check. That one works also, so we have done this correctly. Alright, now we're going to look at number 2. These are two equations in the y-intercept form. So we're first going to be plotting y equals x plus 1. If you recall, we plot the intercept. So our y-intercept is 1, and our slope is 1, because there's a little 1 sitting right in front of that x. You just don't see it. So remember, slope is rise over run, so it's going to be 1 over 1. So we're going to go over and plot this. We have a 1 on the y-axis and a slope of 1. So we go up 1 over 1, up 1 over 1, etc. And we can make this line. Alrighty. I'm going slow so I can be fairly accurate. Okay, moving on to our blue equation. On this equation, we have a y-intercept of -1 and a slope of 3. So that's a rise of 3 over a run of 1. So we're going to plot our -1, count off our slope. Up 3, 1, 2, 3, forward 1. Oh boy, those are right on top. I'm going to do a couple more points. There we go. And now I'm going to draw my line. Sorry, I got kind of wobbly there. Alright, we can now again see our solution is right there. This is 1 in the x and 2 in the y. So we're going to plug those in to check them. So y is 2 equal to an x of 1 plus 1. Well, that's certainly true. Second one, 2 is equal to 3 times 1 is 3 minus 1. Yep, that works too. So again, we have a correct solution. All right, we're going to move on to the last page. Notice I've got three systems to graph. All right, we're going to practice a few more here. So again, we have a slope-intercept. So we're going to do this equation. And our y-intercept is -1. And our slope is 3. Remember, that's 3 over 1. So we plot it. We mark our -1 on the y-axis and count off 3 up to 3n over 1. Give a few more points. Okay, and now we're going to draw this line. Okay, now we're going to do our second equation. This has a y-intercept of 2 and a slope of 3 also. So, mark our y-intercept of 2 and then a slope of 3. The thing is, notice that, oops, that was almost just go over 1. There we are. Notice that 1, 2, 3, 1, 1, 2, 3, 1. We basically end up with a parallel line because it's always going to be 1 away from the first line. So being parallel, we have absolutely no intersection. So that means we have no solutions. Alright, no solution at all. Alright, let's look at this one. Alright, so we have, okay, first equation. We have, okay, we're going to do this with the XY chart. X is 0, Y is 0. When X is 0, I get 3y equals 6, which gives me 6 divided by 3 is 2. When x is 0, I just did that. When y is 0, we get 2x equals 6 divided by 2x is 3. Alright, and now we need one more point. So we're going to do something between 2 and 3, or actually between 0 and 3, and so we're going to do 1 in the x. Well, that gives us 4 plus 6y equals 12. If we subtract the 4, 6y equals, let's get the y. Okay, we're just going to try that one over again. 6y equals 8. 12 minus 4. Divide by 6. Y is equal to a simplified 4/3. Oh, looks like a 9 there. Okay, 4/3. Better. Alright, so we're going to plot this. 0, 2. Nope. 0, 2. 0, 3. 1, 2. Yep, there you go. Alright, that's our line. Alright, now we're going to plot our second equation. We have an x, y. X is 0, y is 0. X is 0, I get 2. 6y equals 12. Divide by 6. Y is 0, I get 4x equals 12. 12 divided by 4 is 3. Alright, well, looky here. Look, these have the exact same points. That's going to be a problem. Let's look at our last number. If I plug in a 1, I get 4 plus 6y equals 12. So 6y equals 8. So y is equal to, again, 4/3. So what this means is I have the exact same line, because I am tracing right over the top of it. So, for my answer, same line, infinite, solutions. Okay, so that's what my answer would be. And now we're looking at the last one, which is a 5, number 5 here. We have one of each type. So, we're going to do our y-intercept form first. So, y-intercept is -4. Slope is -2. So, we have -4. And we do a -2, so we go down 2, forward 1. Or we go up 2, backwards 1. They have to be opposites in positive and negative. Okay. So that's one equation. So we're going to draw our line. Like that. And now we're going to do slope our XY chart, because we're going to do intercepts. So we have 4x minus 2y. So I have an x and a y. 0, 0. When x is 0, y is -4. 8 divided by -2. When y is 0, I get x is 2. 8 divided by 4. So I'm going to plot those. 0, -4. So, 2 in the x, -4 in the y. Oh, look at that. Right on top of our previous point. And 2, 0. Alright, so we're going to choose out one more point just to make sure that our points are correct. Okay, so we're going to do 1 in the x. See, that falls right between the two. I have a 0 and a 2. Alright, so 1 in the x, so that gives me 4 minus 2y equals 8. Subtract 4. Negative 2y equals 4. 8 minus 4. Divide by negative 2. Y is a negative 2. 4 divided by negative 2 is negative 2. So I have 1, negative 2. Yep, sure enough, it smacks right in the middle between my 2 points. And I've got this. And it looks like that's my intersection. This is 0 in the x and negative 4 in the y. So we're going to plug that in and see if it works. Okay, y is negative 4 equals, well, if x is 0, that just goes away. 0 minus 4. Sure enough, negative 4 is negative 4. Okay, that works. Okay, 4 times 0 is 0. Minus 2 times negative 4 is a plus 8 equals 8. Well, sure enough. Okay, so that's correct also. And we're done. Go do your homework. Then work on your mastery. Print it out. Work on your mastery. And you're going to be submitting that in a photo or on a PDF, whatever your system lets you do. Just email it to me.